Hi everyone, welcome back. So today we're going to be continuing 2.6, solving inequalities. The essential question for today is, how do I solve inequalities involving absolute values and polynomials? So the difference between today's lesson and the weekend's lesson is that we're going to be working with inequalities that either involve absolute values or involve polynomials, and we have to solve them in a similar manner to how we did last time. Okay. First one I want to focus on are the inequalities with absolute value. Now in your textbook there is this highlighted portion where it tells you exactly like these special conditions that you can go ahead and jump to a certain conclusion. I'm going to go ahead and abbreviate them here. So if the absolute value of some quantity x is less than a, then negative a less than x less than a. So in other words, then the solution set would be some value x between negative a and a, or you can read it as x greater than negative a, or no, not or, and x less than a. In other words, it has to be a number in between these two numbers. Okay, so it would look something like this, where you have negative a over here you have a, and it's everything in between. Okay. Now the other condition is if absolute value of x is greater than a, then x is less than negative a, or x is greater than a. In other words, you have negative a over here, open circle, going that way, open circle, going that way. So basically your inequality is going to look very different depending on these two guys. The best way to remember it is actually using this mnemonic, less than. In other words, a less than statement will give you an and answer set. If you have greater, then your answer is going to involve the or statement. In other words, you're going to be going into different directions. Okay, so that is a good way to remember it. The only thing I must make sure that you guys realize is that the a value must be positive. Must be positive. Okay? So if it's not positive, it's basically going to work backwards, and you kind of want to make sure that you don't have it that way. So as long as this a value is positive, then you'll be solving it using kind of these special strategies. All right? So with this set, let's go ahead and do example 1. So example 1, we have the absolute value of 2x plus 3 less than 6. So I'm going to make a note to myself. This is probably going to be a less than, thanks to the fact that I have a positive value for my constant and it is a less than statement, which means my answer will most likely look like this, but we'll go ahead and double check after we solve everything. So with the absolute value inequalities, we have to break them up into two separate inequalities. The first one looks exactly the same, just without the absolute value signs. The second, you keep everything on the inside the same, flip the sign, and then change the number on the other side. So now 6 becomes negative 6. From there, you just solve, as you would algebraically. So 2x less than 3. X is going to be less than 3 halves. Over here, subtract 3 again. 2x greater than negative 9. Divide by 2, so x is greater than negative 9 halves. Okay, so luckily this does work out. We're going to have negative 9 halves less than x less than 3 halves. If we were to graph this, 3 halves is just about 1.5, so I'll put 1 right there. And let's go with 2, so 1.5, 3 halves. Negative 9 halves would be about negative 4.5, so 1, 2, 3, 4, 5. Negative 9 halves. No equal symbol, so I'm just going to have an open circle, and a nice big bar in between. Okay, so that is our answer for that inequality involving absolute value. Our less than mnemonic ended up working well for us, And that again, that is because our 6 there, the number on the other side, was positive. If it's not positive, it's not going to work out. So make sure to check for that before you use this trick. The other thing that you might want to use in order to check your answer is, just as always, you can always plug in one of your possible answer choices. So, for example, 0 would be a good one to plug into this problem. So if I were to check it, 2 times 0 plus 3 less than 6. 2 times 0, 0. 0 plus 3, 3. Absolute value of 3. 3 is definitely less than 6. So this works out. This answer set is definitely correct. Alright, we're going to go ahead and move on to polynomial inequalities now. So I'm going to set that in stone. Let's go ahead and move to the next side. Set up my columns as always. Questions, steps. And now we're going to work with polynomial inequalities. Now, the polynomial inequalities aren't difficult to solve. It's checking the answers that becomes kind of difficult, just because there could be many answers and many intervals where our answers might exist. To make that make a little more sense, let's go ahead and do this example problem. We have x squared plus x minus 56 greater than 0. In order to solve this, I do need to break these polynomials as much as possible. In most cases, you might use factoring. You could use the quadratic formula if you have a quadratic equation, or any other way in order to break these down and somehow find your zeros. For this one, nice easy one to factor. I'm going to have x and x. I'm going to have plus 8 and minus 7. And all of this has to be greater than 0. Now here's the tricky part. In order to find my zeros, I actually need to set my terms equal to 0. So even though we're dealing with inequalities, we're actually going to set these equal to 0 and find our zeros first. So x equals 7 and x equals negative 8. So here are my important points on this whole domain. Negative infinity is going to be part of this test interval. The next number we need to test is negative 8. Then all the way over here, it's going to be 7. And then our final interval will be going through infinity. So the way I pulled out these numbers is that I always start with negative infinity and end with infinity. Whatever zeros I get end up being my numbers in between, and I need to check the intervals from here to here, here to here, and here to here. So if you end up with more than 2 roots, then you would have to test another interval in between those. All right. So let's go ahead and test these out. There's multiple ways you could do this. What I want to see is that I'm looking for numbers in between negative infinity and negative 8, negative 8 and 7 and infinity. I need to test numbers from each one of those intervals to see, okay, which ones actually make this inequality greater than 0. In other words, end up with a positive number. One thing you could do is basically just pull out a number. For example, here I could use negative 9. That's in between negative infinity and negative 8. Here I'll definitely choose 0. That's in between those two numbers. Here I'm going to go with 10. 10's nice and easy. So let's go ahead and test out these numbers into the original inequality. So if I were to plug negative 9 in, I would get negative 9 squared plus negative 9 minus 56. Then we have to check, is it greater than 0? 81 minus 9 minus 56. And then just looking at this, I already know that it's going to be positive, but it is 16. So this does end up as positive greater than 0. It works. Let's try out the other one. Now 0 squared plus 0 minus 56. That one instantly I know is less than 0. So because it's negative, this one will not be part of our interval. So I'm going to kind of set that off to the side right there. This one, let's test 10. So 100 plus 10 minus 56. And in relation to 0, I don't know yet, so I'll put a question mark. 110 minus 56 will be 54. 54 is definitely greater than 0, so that is also positive. So I have 2 intervals where I have positive answers that end up making this inequality true. This interval of negative infinity to negative 8, and this interval of 7 to infinity. So my answer for this is going to be negative infinity to negative 8 union 7 to infinity. The reason I'm using parentheses is that my answers do not include negative 8 and 7. If I were to plug in negative 8 and 7, it would turn my inequality into, plugged into the polynomial, it would become 0, which is definitely not greater than 0. However, had I had equals to, then we would definitely have brackets, because then you would include negative 8 and 7. Right? So here's my answer. This U just stands for union. So it's the union symbol that basically says that, okay, these two intervals are your set of answers. Okay? So that is one way that you can use to check your answers for these type of problems. There is another way, and I'm going to show that briefly right now. So what you would want to do is you would set up your factors into a nice little organizer. You would then set up your intervals. So I'm going to have negative infinity, negative 8, 7, and infinity. So here, yep. So basically, I'm going to test some values within these intervals. Okay. Down here, I'm going to have my polynomial. Alright, so let me actually move this over. It should be right there. So basically, a number in between negative infinity and negative 8 for just x plus 8. The reason this one might work a little easier for some people is because it focuses a lot more on just these factors, and it might be easier for you. So if I were to plug in a negative number such as negative 10, this one would definitely end up negative. Here, if I were to put a negative number, it would end up even more negative. Here, I'm going to plug in 0, so 0 plus 8, that's positive. 0 minus 7, that stays negative. Then between 7 and infinity, I'm going to get, well, if I plug in a 9 or a 10, that's going to make that one positive. Plug this one in, anything at this point will be positive. And then what I'm going to do, since these are factors of the entire polynomial, I'm going to multiply them, because that's what you do with factors. So negative times negative, positive. Positive times negative, negative. Positive times positive, positive. In other words, my intervals are supposed to be negative infinity to negative 8, along with 7 to infinity. Alright, so that is another way that you can verify your answer using this little organizer that might help out for some of you. It works with smaller factors in terms, so it might make it slightly easier than plugging into a super long, complicated polynomial. Right? And that's only if you get factors broken out. Okay, so a lot to go over. Review, replay if needed, and go ahead, go to the Google Forms. Have a nice evening, you guys.